Good evening, and welcome to Boring Books for Bedtime. I hope tonight's installment provides all the boredom your busy brain needs to quiet down and let you get some sleep for once. So lie back, adjust your volume, take a nice deep breath, and off we go. Before we begin this evening's reading, I want to give a special shout out of thanks to the latest member of our Patreon family, Nina. Nina, thank you so much for becoming a patron of this podcast. It's much appreciated. If you're interested in finding out about the exclusive perks available to our supporters, you'll find a link to our Patreon page in the show description. Now, let's get to this evening's reading. Tonight, we're enjoying a special little volume, Astronomy for Young Folks by Isabel Martin Lewis, A.M., connected with the Nautical Almanac Office of the U.S. Naval Observatory. Copyright 1921 by the Century Company and 1922 by Duffield & Company, New York. Let's begin. Preface. Astronomy, it has been said, is the oldest and the noblest of the sciences. Yet it is one of the few sciences for which most present-day educators seem to find little, if any, room in their curriculum of study for the young, in spite of its high cultural value. It is, we are told, too abstruse a subject for the youthful student. This is doubtless true of theoretical or mathematical astronomy, and the practical astronomy of the navigator, surveyor, and engineer, but it is not true of general descriptive astronomy. There are many different aspects of this many-sided science, and some of the simplest and grandest truths of astronomy can be grasped by the intelligent child of 12 or 14 years of age. Merely as a branch of nature study, the child should have some knowledge of the sun, moon, stars, and planets, their motions, and their physical features, for they are as truly a part of nature as are the birds, trees, and flowers. And the man, woman, or child who goes forth beneath the starlit heavens at night, absolutely blind to the wonders and beauties of the universe of which he is a part, loses as much as the one who walks through field or forest with no thought of the beauties of nature that surround him. The astronomer is the pioneer and explorer of today in realms unknown, just as the pioneers and explorers of several centuries ago were to some extent astronomers, as they sailed unknown seas and traversed unexplored regions. As the years pass by, the astronomer extends more and more his explorations of the universe, and brings back among the fruits of discovery measures of giant suns and estimates of the form and extent of the universe, views of whirling, seething nebulae, mysterious dark clouds drifting through space, tremendous solar upheavals, or glimpses of strangely marked surfaces of nearby planets. In the following pages, the author has endeavored to tell in words not beyond the comprehension of the average 14-year-old child something of the nature of the heavenly bodies. In Part 1, an effort is made to make the child familiar with the stars by indicating when and where they can be found in the early evening hours. In addition to identifying the principal constellations and their brightest stars by means of diagrams, an attempt has been made to acquaint the child with the most interesting recent discoveries that have been made concerning the principal stars or objects in each group, as well as with some of the stories and legends that have been associated with these groups of stars for centuries, and that have been handed down in the folklore of all nations. Chapters 2 to 13 inclusive appeared originally with diagrams similar to those shown here under the Department of Nature and Science for Young Folk in St. Nicholas from May 1921 to April 1922 inclusive. The introductory chapter and chapters 14 and 15 on the Milky Way and stars of the Southern Hemisphere are published here for the first time, as is also the chapter in Part 2 on the evolution of the stars from red giants to red dwarfs, which gives the order of the evolution of the stars as now accepted as a result of the brilliant astronomical researches of Dr. Henry Norris Russell of the United States and Professor A.S. Eddington of England. The remaining chapters in Part 2 have been chosen from a series of articles that have appeared in Science and Invention, formerly the Electrical Experimenter, in the past 4 years, and have been considerably revised and in some parts rewritten to adapt them to the understanding of more youthful readers. These chapters deal with a variety of astronomical subjects of general popular interest, and an effort has been made to select subjects that would cover as wide an astronomical field as possible in a limited space. The author's aim has not been to write a textbook of astronomy, or to treat in detail of any one aspect of this extensive science, but simply to give the average child some general knowledge of the nature of the heavenly bodies, both those that form a part of our own solar system and those that lie in the depths of space beyond. It has been necessary to write very briefly, and we feel inadequately, of many topics of special interest, such as the sun and moon. Books have been written on these two subjects alone, as well as upon such subjects as Mars, eclipses, comets, meteors, etc., but the object has been to acquaint the child with the outstanding features of a variety of celestial objects, rather than to treat of a few in detail. If the writer succeeds in arousing the child's interest in the stars, so that he may look forth with intelligence at the heavens and greet the stars as friends, and at the same time grasps some of the simplest and most fundamental of astronomical truths, such as the distinction between stars and planets, the motions of the heavenly bodies, and their relative distances from us, and the place of our own planet world in the universe, this book will have served its purpose. Astronomy for Young Folks. Quote, "The heavens declare the glory of God, and the firmament showeth his handiwork." End quote. Psalm 19. Chapter 1. The Constellations. Quote, "Canst thou bind the sweet influences of the Pleiades, or loose the bands of Orion? Canst thou bring forth Mazzaroth in his season, or canst thou guide Arcturus with his sons?" End quote. The Book of Job. Who would not like to know the stars and constellations by their names and in their seasons, as we know the birds and the trees and the flowers? To recognize at their return, year by year, Sirius and Spica, Arcturus and Antares, Vega and Altair. To know when Ursa Major swings high overhead, and Orion sinks to rest beneath the western horizon, when Leo comes into view in the east, or the northern crown lies overhead. Often we deprive ourselves of the pleasure of making friends with the stars and shut our eyes to the glories of the heavens above because we do not realize how simple a matter it is to become acquainted with the various groups of stars as they cross our meridian one by one, day after day, and month after month, in the same orderly sequence. When the robin returns once more to nest in the same orchard in the springtime, Leo and Virgo may be seen rising above the eastern horizon in the early evening hours. When the first snow flies in the late fall, and the birds have all gone southward, the belt of Orion appears in the east, and Cygnus dips low in the west. When we once come to know brilliant blue-white Vega, ruddy Arcturus, golden Capella, and sparkling Sirius, we watch for them to return each in its proper season and greet them as old friends. In the following pages, we give for each month the constellations or star groups that are nearest to our meridian, that is, that lie either due north or due south or exactly overhead in the early part of the month and the early part of the evening. We do not need to start our study of the constellations in January. We may start at any month in the year, and we will find the constellations given for that month on or near the meridian at the time indicated. In using the charts or diagrams of the constellations, we should hold them in an inverted position, with the top of the page toward the north, or else remember that the left-hand side of the page is toward the east, and the right-hand side of the page toward the west, which is the opposite of the arrangement for charts and maps of the Earth's surface. We should also bear in mind that the constellations are all continually shifting westward, for the stars and the moon and the planets, as well as the sun, rise daily in the east and set in the west. This is due to the fact that the Earth is turning in the opposite direction on its axis, that is, from west to east. In 24 hours, the Earth turns completely around with respect to the heavens, or through an angle of 360 degrees. So in 1 hour, it turns through an angle of 360 degrees divided by 24, or 15 degrees. As a result, the stars appear to shift westward 15 degrees every hour. This is a distance about equal in length to the handle of the Big Dipper, which I am sure we all know, even if we do not know another constellation in the heavens. If, then, we look to the heavens at a later hour than that for which the constellations are given, we will find them farther westward. And if we find our time of observation is earlier in the evening than the hour mentioned, we will find them farther eastward. In the course of a year, the Earth makes one trip around the Sun and faces in turn all parts of the heavens. That is, it turns through an angle of 360 degrees with respect to the heavens in a year, or through an angle of 360 degrees divided by 12, or 30 degrees in 1 month. So, as a result of our revolution around the Sun, which is also in a west to east direction, we see that all the constellations are gradually shifting westward at the rate of 30 degrees a month. It is for this reason that we see different constellations in different months, and it is because of the turning of the Earth on its axis that we see different constellations at different hours of the night. If we should sit up from sunset to sunrise and watch the stars rise in the east, pass the meridian, and set in the west, as the sun does by day, we should see in turn the same constellations that are to pass across the heavens in the next 6 months. This is because in 12 hours' time we are carried through the same angle with respect to the heavens by the Earth's rotation on its axis that we are in the next 6 months by the motion of the Earth around the Sun. Let us suppose, then, that the time we choose for our observation of the heavens is the last of the month, while our charts are given for the first of the month. We must look then farther westward for our constellations, just as we must look farther westward if we chose a later hour in the evening for our observations. Let us suppose that we choose for our time of observation 8:30 in the early part of December. On or close to the meridian, we will find the constellations outlined in the charts for December. To the east of the meridian, we will find the constellations that are given for January and February, and to the west of the meridian, the constellations that are given for November and October. So, if we are particularly ambitious or wish to become acquainted with the constellations more rapidly, we may study at the same time the constellations for the preceding months now west of the meridian, and the constellations for the following months now east of the meridian, as well as the constellations for the month which will be due north or south, or directly overhead, as the case may be. If we were able to see the stars by day as well as by night, we would observe that as the days go by, the sun is apparently moving continuously eastward among certain constellations. This is a result of the Earth's actual motion around the sun in the same direction. The apparent path of the sun among the stars is called the ecliptic, and the belt of the heavens 8 degrees wide on either side of the ecliptic is called the zodiac. The constellations that lie within this belt of the zodiac are called zodiacal constellations. The zodiac was divided by the astronomer Hipparchus, who lived 161 to 126 BC, into 12 signs 30 degrees wide, and the signs were named for the constellations lying at that time within each of these divisions. These zodiacal constellations are Aries, Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpio, Sagittarius, Capricornus, Aquarius, and Pisces. With the exception of Libra, the scales, all of these constellations are named for people or animals, and the word zodiac is derived from the Greek word meaning of animals. Each month, the sun moves eastward 30 degrees through one of these zodiacal constellations. In the days of Hipparchus, the sun was in Aries at the beginning of spring, at the point where the ecliptic crosses the celestial equator, which lies directly above the Earth's equator. This point where the ecliptic crosses the equator was then known as the first point in Aries. The autumnal equinox was 180 degrees distant in Aquarius, and the 2 points were called the equinoxes, because when the sun is at either equinox, the day and night are equal in length all over the world. Now, for certain reasons, which we will not explain here, the equinoctial points are not fixed in position, but shift gradually westward at the rate of 1 degree in 70 years. It is as if the equinoxes were advancing each year to meet the sun on its return, and their westward motion is therefore called the precession of the equinoxes. Since the days of Hipparchus, this motion has amounted to about 30 degrees, so that the constellations no longer occupy the signs of the zodiac that bear their names. The sun is now in Pisces instead of Aries at the beginning of spring, and in Virgo instead of Aquarius at the beginning of fall. Not only the sun, but the moon and planets as well move through the zodiacal constellations. In fact, a limit for the zodiac of 8 degrees on either side of the ecliptic was chosen because it marks the extent of the excursions of the moon and planets from the ecliptic. Neither moon nor planets will be found at a greater distance than 8 degrees on either side of the ecliptic. For convenience in determining the positions of the heavenly bodies, the astronomer assumes that they lie upon the surface of a celestial sphere that has its center at the center of the earth. The north pole of the celestial sphere lies directly above the north pole of the earth, and the south pole of the celestial sphere directly above the south pole of the earth. The celestial equator is the great circle of the celestial sphere that lies midway between its north and south poles, and directly above the Earth's equator. The ecliptic is also a great circle of the celestial sphere, and cuts the celestial equator at an angle of 23½ degrees in the 2 points 180 degrees apart, known as the equinoctial points, of which we have already spoken. The zodiacal constellations lie nearly overhead within the tropics, and can be seen to advantage all over the world except in polar regions. For every position of the Earth's surface except at the equator, we have also our circumpolar constellations, which are the ones that never pass below the horizon for the place of observation. In 40 degrees north latitude, the Big Dipper is a circumpolar constellation, for it is above the horizon at all hours of the day and night and all times of the year. If our latitude is 40 degrees north, all stars within 40 degrees of the North Pole of the heavens are circumpolar and never set, while stars within 40 degrees of the South Pole of the heavens never rise. All other stars rise and set daily. If we were at the North Pole, all stars within 90 degrees of the North Pole of the heavens would be circumpolar, and would describe daily circuits of the pole parallel to the horizon remaining always above it. If we were at the equator, all stars within 0 degrees of either pole would be circumpolar. That is, no stars would be circumpolar, all stars rising and setting daily. As a general rule, then, we may say that stars within an angular distance of the nearest pole of the heavens equal to the latitude never set, and stars within an equal distance of the opposite pole never rise, while all stars outside of these limits rise and set daily. The beginner who attempts to make the acquaintance of the principal stars and constellations occasionally may find a bright star in a constellation that is not noted in the diagrams. In this case, he has probably happened upon one of the bright planets. it is not possible to include the planets in our diagrams for the reason that they are not fixed in position, but apparently wander among the stars. The name planet is, in fact, derived from a Greek word meaning wanderer. The stars shine by their own light, but the planets shine only by reflected light from the sun. Of the 7 planets in the solar system additional to our own planet, Earth, there are 2, Uranus and Neptune, that we need not consider, for Neptune is not visible without the aid of a telescope, and Uranus is fainter than any of the stars included in our diagrams. Mercury will never appear except in the morning or evening twilight, when none but the very brightest stars are visible, since it never departs far from the sun. It will only be seen under certain favorable conditions, and usually it will escape our notice altogether unless we know exactly where to look for it, although there are but 2 or 3 stars in the heavens that surpass it in brightness. Venus we will probably never mistake for any star in the heavens, for it far surpasses all stars in brightness. It will always be seen in the west after sunset, or in the east before sunrise, and it is never seen more than 3 hours before or after the sun. This leaves us but 3 planets, Jupiter, Saturn, and Mars, that we may mistake for bright stars. There is little chance that Jupiter will be thus mistaken, for it also is far brighter than all of the stars except Sirius, which differs greatly from Jupiter in color. Sirius is a brilliant white, and Jupiter is a golden yellow. The planets do not twinkle as the stars do, and this is particularly true of Jupiter, which is remarkable for the quiet steadiness of its yellow light. This alone would serve to identify it. Saturn is probably mistaken for a star oftener than any of the other planets. It moves so slowly among the stars that we would have to watch it for a number of successive evenings before we could discover that it is moving with respect to the stars. Saturn is yellowish in color, and we can probably best distinguish it by the steadiness of its light. If we find in one of the zodiacal groups of stars, for the planets appear among no other constellations, a bright yellowish star where no bright star is indicated on the diagram, we may be reasonably certain that we have found the planet Saturn. Mars is the only planet that is reddish in color. Once in 15 or 17 years, when it is particularly near to the Earth, it surpasses even Jupiter in brightness, but ordinarily it appears no more brilliant than one of the brighter stars. There are only 2 stars with which we are likely to confuse Mars, Aldebaran and Antares, which are very similar to it in color and at times in brightness. Moreover, both of these stars are zodiacal stars, and Mars frequently passes through the constellations to which they belong. There should be no trouble about identifying Aldebaran and Antares, however, from their distinctive positions in the diagrams, so that any other reddish star appearing in any of the zodiacal groups we may feel certain is the planet Mars. In the following diagrams of the constellations, the brightest and most conspicuous stars, called first magnitude stars, are represented by white stars. These are the stars we should all be able to recognize and call by name, and in every instance, the name of a first magnitude star is given on the diagram. All other stars are represented by circles, and the size of the circle is an indication of the brightness of the star. Stars visible without the aid of a telescope are referred to usually as naked eye stars. They are classed as first, second, third, fourth, fifth, or sixth magnitude stars according to their relative brightness. A star of the first magnitude is about 2.5 times brighter than a star of the second magnitude, which in turn is 2.5 times brighter than a star of the third magnitude, and so on. A first magnitude star is then 100 times brighter than a sixth magnitude star, which is the faintest star that can be seen without the aid of a telescope. This ratio between successive magnitudes continues among the telescopic stars. A star of the sixth magnitude is 100 times brighter than a star of the 11th magnitude, which in turn is 100 times brighter than a star of the 16th magnitude. The faintest stars that can be seen visually in the greatest telescopes are of the 17th or 18th magnitude. Those stars 2 or 3 magnitudes fainter can be photographed. The faintest stars shown in the diagrams are 5th magnitude stars, and stars of this magnitude, as well as stars of the 4th magnitude, are only given when needed to fill out the distinctive outlines of the constellations, which have been formed by connecting the principal stars in each group by dotted lines. All stars of first, second, and third magnitude are given in the diagrams without exceptions, as such stars are visible to everyone on clear nights. The constellations given in the following pages include practically all of the constellations that can be seen in 40 degrees north latitude. A diagram is given for each constellation. In this latitude, it is impossible to see the constellations of the southern hemisphere that lie within 40 degrees of the south pole of the heavens. A brief chapter with diagrams treats of these constellations that are invisible in mid-latitudes of the northern hemisphere. Chapter 2. January. One of the most easily recognized constellations in the heavens is Taurus, the Bull, a zodiacal group which lies just south of the zenith in our latitudes in the early evening hours, about the 1st of January. Taurus is distinguished by the V-shaped group of the Hyades, which contains the bright red first magnitude star Aldebaran, representing the fiery eye of the bull. It also contains the famous cluster of faint stars known as the Pleiades, lying a short distance northwest of the Hyades. No group of stars is more universally known than the Pleiades. All tribes and nations of the world, from the remotest days of recorded history up to the present time, have sung the praises of the Pleiades. They were the many little ones of the Babylonians, the 7 sisters of the Greeks, the 7 brothers of the American Indians, the hen and chickens of many nations of Europe, the little eyes of the South Sea Islanders. They were honored in the religious ceremonies of the Aztecs, and the savage tribes of Australia danced in their honor. Many early tribes of men began their year with November, the Pleiad month, and on November 17th, when the Pleiades crossed the meridian at midnight, it was said that no petition was ever presented in vain to the kings of ancient Persia. Poets of all ages have felt the charm of the Pleiades. Tennyson gives the following beautiful description of the Pleiades in Locksley Hall. Quote, "Many a night I saw the Pleiades rising through the mellow shade, glitter like a swarm of fireflies tangled in a silver braid." End quote. A well-known astronomer not so many years ago also felt the mysterious charm of the Pleiades and seriously expressed the belief that Alcyone, the brightest star of the Pleiades, was a central sun about which all other suns were moving. But we know now that there is no foundation whatever for such a belief. A fairly good eye, when the night is clear and dark, will make out 6 stars in this group, arranged in the form of a small dipper. A 7th star lies close to the star at the end of the handle and is more difficult to find. It is called Pleione and is referred to in many legends as the lost Pleiad. Persons gifted with exceptionally fine eyesight have made out as many as 11 stars in the group, and with the aid of an ordinary opera glass, anyone can see fully 100 stars in this cluster. Astronomers have found that the Pleiades cluster contains at least 250 stars, all drifting slowly in the same general direction through space, and that the entire group is enveloped in a fiery nebulous mist, which is most dense around the brightest stars. It is not known whether the stars are being formed from the nebula or whether the nebula is being puffed off from the stars. The brightest star, Alcyone, is at least 200 times more brilliant than our own sun, and all of the brighter stars in the group surpass the sun many times in brightness. It is believed that this cluster is so large that light takes many years to cross from one end of it to the other, and that it is so far from the Earth that its light takes over 3 centuries to reach us, traveling at the rate of 186,000 miles a second. The Hyades is a group of stars scarcely less famous than the Pleiades, and the stars in the group also form a moving cluster of enormous extent at a distance of 140 light years from the Earth. Among the ancients, the Hyades were called the rain stars, and the word Hyades is supposed to come from the Greek word for rain. Among the many superstitions of the past was the belief that the rising or setting of a group of stars with the sun had some special influence over human affairs. Since the Hyades set just after the sun in the showery springtime, and just before sunrise in the stormy days of late fall, they were always associated with rain. In Tennyson's Ulysses, we read, quote, "Through scudding drifts, the rainy Hyades vexed the dim sea." End quote. The Hyades outline the forehead of Taurus, while 2 bright stars some distance to the northeast of the V form the tips of the horns. Only the head and 4 quarters of the bull are shown in the star atlases that give the mythological groups. For according to one legend, he is swimming through the sea, and the rest of his body is submerged. According to another legend, Taurus is charging down upon Orion the warrior, represented by the magnificent constellation just to the southeast of Taurus, of which we shall have more to say next month. Aldebaran is the Arabic word for the hindmost, and the star is so called because it follows the Pleiades across the sky. It is one of the most beautiful of all the many brilliant stars visible at this time, and we might profit by following the advice of Mrs. Sigourney in The Stars. Quote, "Go forth at night and talk with Aldebaran, where he flames in the cold forehead of the wintry sky." End quote. Next to Aldebaran in the V is the interesting double star Theta, which we can see as two distinct stars without a telescope. Directly south of Taurus is Eridanus, sometimes called Fluvius Eridanus or the river Eridanus. Starting a little to the southeast of Taurus, close to the brilliant blue-white star Rigel in Orion, it runs to the westward for a considerable distance in a long, curving line of rather faint stars, bends sharply southward for a short distance, then curves backward toward the east once more, and after running for some distance, makes another sharp curve to the southwest and disappears below the southern horizon. Its course is continued far into the southern hemisphere. Its brightest star, Achernar, is a star of the first magnitude, but it lies below the horizon in our latitudes. Eridanus contains no star of particular interest to us. Most of the numerous stars that mark its course are of the 4th and 5th magnitude. It contains but 2 stars of the 3rd magnitude, one at the beginning of its course and one close to the southwestern horizon. The beautiful constellation of Perseus lies just to the north of Taurus, and should rightfully be considered among the constellations lying nearest to the meridian in January. But we give this constellation among the star groups for December because of its close association with the nearby constellations Andromeda and Pegasus in legend and story. Chapter 3. February. Across the meridian due south, between 8 and 9 o'clock in the evening in the early part of February, lies Orion, the warrior, generally considered to be the finest constellation in the heavens. Orion is directly overhead at the equator, and so is seen to advantage from all parts of the world except the extreme northern and southern polar regions. A group of 3 faint stars outlines the head of Orion. His right shoulder is marked by the deep red 1st magnitude star Betelgeuse, meaning armpit, and his left shoulder by the bright white star Bellatrix, the Amazon. Orion stands facing Taurus the bull and brandishes in his right hand a club outlined by a number of faint stars extending from Betelgeuse toward the northeast. The top of the club lies near the tips of the horns of Taurus. In his left hand he holds up a lion's skin, which we can trace in another curving line of faint stars to the west and northwest of Bellatrix. The brilliant blue-white 1st magnitude star Rigel lies in the left foot, and the 2nd magnitude star Saiph, a little to the east of Rigel, is in the right knee. 3 evenly spaced stars lying in a straight line that is exactly 3 degrees in length form the belt of Orion, and from the belt hangs the sword of Orion, outlined by 3 faint stars. The central star in the sword appears somewhat blurred and is the multiple star Theta in the midst of the great Orion Nebula, the finest object of its kind in the heavens. Entangled in the meshes of this glowing nebula are a number of brilliant suns, appearing to us as faint stars because of their great distance. The star Theta in the heart of the nebula is seen with a powerful telescope to consist of 6 stars. That is, it is a sextuple star. Even with a small telescope, 4 of these stars can readily be seen arranged in the form of a small trapezium. The lowest star in the sword is a triple star, and the entire constellation abounds in double, triple, and multiple stars. From the central portion of the nebula extend many branches and streamers of nebulous light, and it is known that the entire constellation of Orion is enwrapped in the folds of this nebulosity, which forms a glowing, whirling mass of fiery gases in rapid rotation. This constellation is remarkable for the fact that all of its brighter stars, with the exception of the deep red Betelgeuse, form one enormous connected group of stars. They are all more or less associated with the great nebula and its branches, and are all extremely hot, white or bluish-white stars, known as helium stars, because the gas helium is so conspicuous in their atmospheres. The Orion stars are the hottest and brightest of all the stars. Blazing Rigel, Bellatrix, and Saiph, marking 3 corners of the great quadrilateral of which Betelgeuse marks the 4th corner, are all brilliant helium stars. So are the 3 stars in the belt, and the fainter stars in the sword and the great nebula. It has been estimated that the great Orion group of stars is over 600 light-years from the Earth, or about 40 million times more distant than the Sun. For more than 6 centuries, the rays of light that now enter our eyes from these stars have been traveling through space with the speed of lightning. So we see Orion not as it exists today, but as it was 6 centuries ago. The extent of the Orion group of stars is also inconceivably great. Even the central part of the great nebula, which appears to our unaided eyes only as a somewhat fuzzy star, would extend from here to the nearest star and beyond, while our entire solar system would be the merest speck in its midst. Betelgeuse, the red star that marks the right shoulder of Orion, is, as we have said, not a member of the Orion group. It has been estimated that it is about 200 light-years from the Earth, or only about 1/3 as far away as the other stars of the constellation. Betelgeuse very recently has attracted universal attention and will probably be considered an object of historic interest in the future, because it is the first star to have its diameter measured with the new Michelson interferometer, which is now being used so successfully to measure the diameters of the largest stars. The truly sensational discovery has been made that Betelgeuse is a supergiant of the universe, with a diameter of about 275 million miles. Our own Sun, which is known as a dwarf star, has a diameter of 864,000 miles. That is, Betelgeuse would make about 30 million suns the size of our own. If placed at the center of the solar system, it would fill all of the space within the orbit of Mars, and the planets Mercury, Venus, and the Earth would lie far beneath its surface. Measurements of the diameters of other giant stars, which are now being made with the interferometer, give results quite as startling as have been obtained in the case of Betelgeuse, and it has been found that several of these stars may even exceed Betelgeuse in size. Such a star is Antares, the fiery red star in the heart of Scorpio, which is such a conspicuous object in the summer evening skies. All these huge stars are deep red in color, and some of them vary irregularly in brightness. Betelgeuse is one of the stars that changes in brightness in a peculiar manner from time to time. When shining with its greatest brilliancy, it is a brighter object than the nearby star Aldebaran in Taurus. But a few months or a year later, it may lose so much of its light as to be decidedly inferior to Aldebaran. We may note for ourselves this remarkable change in the brightness of Betelgeuse by comparing the two stars from time to time. Directly south of Orion lies the small constellation of Lepus, the Hare, which is made up of third magnitude and fourth magnitude stars. The four brighter stars are arranged in the form of a small but distinct quadrilateral, or four-sided figure, which may be easily seen in our latitudes. The small constellation of Columba, the Dove, which lies just south of Lepus, is so close to the horizon that it cannot be seen to advantage in the mid-latitudes of the northern hemisphere. Neither Lepus nor Columba contain any object of unusual interest. Due north of Orion and lying in the zenith at this time is Auriga, the charioteer, represented, strange to say, with Capella, a goat, in his arms. The beautiful first magnitude star Capella, golden yellow in color, serves us in identifying the constellation. Close at hand are the Kids, represented by a group of three faint stars. Capella is one of the most brilliant stars of the northern hemisphere. It is almost exactly equal in brightness to Arcturus and Vega, stars conspicuous in the summer months, and it is a shade brighter than magnificent blue-white Rigel in Orion. Capella is about 50 light-years distant from the Earth, and is fully 200 times more brilliant than our own Sun. At the distance of Capella, the Sun would appear to be considerably fainter than any one of the three stars in the nearby group of the Kids. Capella is attended by a companion star so close to its brilliant ruler that it cannot be seen as a separate star, save with the aid of the most powerful telescopes. Its distance from Capella has been very accurately measured, however, by means of the interferometer, which is giving us the measurements of the diameters of the giant stars. It is known that this companion star is closer to Capella than our planet Earth is to the Sun. At no time of the year shall we find near the meridian so many brilliant and beautiful stars as appear in the month of February at this time in the evening. In addition to Capella, which is one of the three most brilliant stars in the northern hemisphere of the heavens, we have in Orion alone 2 stars of the first magnitude, Betelgeuse and Rigel, and 5 stars of the second magnitude, Bellatrix and Saiph, and the 3 stars in the belt. In addition, we have not far distant in the western sky fiery Aldebaran in Taurus, and close on the heel of Orion in the east, Sirius, the brightest star in the heavens, in the constellation of Canis Major, the greater dog, as well as the first magnitude star Procyon in Canis Minor, the lesser dog. Of these two groups, we shall have more to say under the constellations for March. And with that, I think we'll end this evening's reading from Astronomy for Young Folks by Isabel Martin Lewis. We'll definitely be returning to this marvelous little book, which I hope you enjoyed as much as I did. Hopefully, you're no longer awake to hear this, but if you are and you'd like to read this work for yourself, you'll find a link to a free ebook version from Project Gutenberg in the show description. If you'd like to connect or suggest a boring book you'd like to hear read, the best place to catch me is on Twitter at BoringBooksPod. I'd love to hear from you. Thank you so much for joining me this evening. Until our next boring book, good night.